Hello, this video will cover section 1.4 factoring for the class Math 0305 with the co-requisite of Math 1324. This video is the second part of this section 1.4, and so the last problem that was covered on part 1 of this video, I'm just going to go ahead and write the answer here. So it was x plus 2 and then x plus 3 and x minus 3. And we were left off by factoring the x plus 3 and the x minus 3 were the factors of the binomial x squared minus 9, which we called a difference of squares. And so that is what we have here. We're going to do more examples in the next page, from the next page. So what we're going to focus on right now is factoring trinomials. So trinomials have 3 terms, and so that will be x squared, that's one term, bx is the second term, and c is the third term. So I'm going to start with the easy ones because the leading coefficient, the coefficient of the x squared, is just a 1. And so those are pretty easy to factor. Then we're going to move on to the ones where the leading coefficient is not a 1. It could be any other number. So let's go ahead and start with example 11. So in this case, we have we have 3 terms, so that's a trinomial. So we're going to factor it into the product of 2 binomials. Now, the only way to get x squared is by multiplying x times x. Now, for our signs, if this sign is negative, that means that we must have a positive and a negative following the x. So I call this one of each of the signs. Now we're going to list the factors of 6, and so those could be 1 and 6 or 2 and 3. Now remember what I mentioned on the previous video, that I like to write them in this order, small and large. And keep in mind that we're trying to find the factors of -6. So one of our columns needs to be negative and the other column positive. So for that, we look at the second sign of the trinomial, which is a negative. And so that tells me that the number or the factor with the largest absolute value will carry that negative sign. So this will be negative, negative, positive, and positive. And so if we look at them, which combination will give me a -1x? So that would be +2 and -3, because 2 minus 3 is -1. So we can have +2 here and -3 here. Now, to check our work, we could multiply our terms on the outside. So x times 3 will be 3x. And then our terms on the inside, which will be 2 times x. Oh, I'm sorry, x times -3, so that will be -3x. And then the terms on the inside, 2 times x positive, so 2x. And if we combine those, we will get -x, which is the term that we were looking for right here. Now, I'm going to go ahead and move on to example 12. And so for example 12, again, we start by factoring by opening the parentheses for our 2 binomials. And now in this case, we're going to look at our signs, and this one is positive. So the only way you can get a positive sign is if the constant terms that we will write down here and here are either both positive or both negative. So, and that is because 2 positive numbers multiplying each other will give you a positive. And if you have 2 negative numbers multiplying each other, you will also get a positive. So now, the way we will decide which combination we will go with is based on this sign. It's a positive, so that means that both of our signs must be positive. And so that's what we're going to use. So our signs both positive. Now we're going to list the factors of 60, positive 60, so we could have 1 and 60, 2 and 30, 3 and 20, 4 and 15, also 5 and 12, and finally 6 and 10. And so in this case, we're saying both of our factors will be positive. So if we add them, which combination will give us positive 16? And that will be positive 6 and positive 10. Now to check our answer, we could go ahead and multiply again the 2 on the outside. X times 10 is 10x. And then positive 6 times positive x will be positive 6x. If we add them, we will get positive 16x, which is what we had here. So that is the correct factorization for that polynomial. So now moving on to problem 13, we also have a trinomial. And so we are going to start by writing our 2 sets of parentheses. Then we're going to factor x squared, so that is only x times x. Now we notice the sign is positive, so remember we said that could be either both signs are positive of your constant terms or both are negative. So we need to check the second sign, the one from the negative 7x, and so that will tell me that we will go with this combination this time, so both will be negative. Now we need to list the factors of 12, so that could be 1 and 12, 2 and 6, 3 and 4. And now keep in mind that we said that all of them are negative. So if we combine them, which combination will give me negative 7? And that will be here, negative 3 and negative 4. And so that will be the factorization for that problem. Now we're going to move on to the ones where the leading coefficient is different than 1. And so sometimes those could get a little lengthy. But there are several methods to factor them. One of them is the trial and error, which is what we're going to practice here. In fact, we're going to use that one for the example 14 and 15. The one with example 14, after doing trial and error, it's not too difficult. I was actually able to find it the first time, but I think I just got lucky on that. So we start by writing our 2 sets of parentheses. Now we have to factor 2x squared, so that could only be 2x and x. Now that is easy because 2 is a prime number, so it's just easy to factor that into 2x and x. But imagine if that was a 6x squared. 6 has several combinations, so it could have been 2x times 3x, or it could have been x times 6x, or yeah, and then we can also consider both positive or both negative. So we're not going to worry about that. And instead, since like I said, we were lucky that 2 is a prime number, we can just factor it that way. So now we look at our constant term, which is a 4, negative 4 actually. And so that's what we're going to do, write our factors of 4. Of negative 4 actually. And so that will be 1 and 4 or 2 and 2. Since it is negative, we know that we could have this issue. 1 will be positive, 1 will be negative. However, we don't know if we're going to use 1 and 4 or 2 and 2. So I'm going to make two combinations. So that will be 2x and x, and then our signs, we're going to switch them. Actually, we're going to put negative here and we're going to put positive here. So now I'm just going to take a chance and pick a combination of 1 and 4. So I'm going to start with, I don't want to cheat because it's actually the first one, but I want to show you what will happen if it's not correct. So if I put my 1 here and my 4 here, and then we do that checking process, we will have 2x multiplied by 4. So that will give us 8x. And then we will have negative 1 multiplied by x, so that will be negative x. And if we combine those, we will get positive 7x. And if you notice, we're almost there except for the sign. We need negative sign. So that tells me this is not the right combination. So then I'm going to use the other combination. Same numbers, but opposite signs. So then I'm going to put the 1 here and the 4 here. So now I'm going to check that. And 2x times negative 4 is negative 8x. And then we have positive 1 times positive x, that is positive x. And so if we add those, it will be negative. Now I'm going to write it here, negative 7x. And if you notice, that is what we needed. So then that will be our answer. Those will be our factors. Now for the next problem, we have another trinomial that we need to factor. And in this case, we start the same way. So for 2x, we will have 2x and x. Then factors of negative 15. We could have 1 and 15 or 3 and 5. Now, we're saying negative, so then 1 will be positive and 1 will be negative, of course. However, we don't know which one is which. And to be honest, this one got a little hectic for me. I'm going to show you some of the possible combinations that I had. And also because this is negative. So I could have the following. I could have positive here, negative here, negative here. Or I can have positive here and negative, positive and negative. And of course, I can have like plenty others. So if I try to use the first one, 1 and 15, by the time I check to see if I get positive 1x, I will be getting numbers that are pretty big. So 2x times negative 15 is negative 30x. 1 times x is positive x. And if we combine that, we will get negative 19x. So that is not going to work at all. Now, if I try to have the 5 here and the 1 here, and by the time I check, I will be getting 2x times negative 1, that's negative 2x, and then 15 times x will be positive 15x. By combining those, I will get 13x positive, and so that's not what we're looking for. Remember, we're looking for positive 1x. Now, if I try, so I'm kind of like giving up on 1 and 15 because 15 is a large number, and I don't want to be getting coefficients such as this one's here. So I'm going to try now with 3 and 5. So I'm going to place my positive 3 here and sorry, this should be negative actually. So I'll be placing a negative sign here. And so this should be positive. Okay, so I'm going to place my positive 3 there and then my negative 5 here. So let's see if we could check. Well, let's see if we have the right factors. So 2x times negative 5 is negative 10x. Then positive 3 times x is positive 3x. If we combine them, we will get negative 7x. And so that is not what we're looking for. So now I'm going to try to have my negative 5 here and my positive 3 here and see what happens. So if I multiply 2x times positive 3, I will get positive 6x. If I multiply negative 5 times x, I will get negative 5x. And 6x minus 5x will be positive 1x. And that was what we were looking for. So now here, these are not the only combinations that we could potentially have to check for. So I just wanted to show you how tedious the guess and check method could be. So now I'm going to show you a different one, and hopefully you find this one better. It could save you some time. And for example, I will really like to use it here because we have 8 as our constant term, in fact, negative 8. So having a negative constant is already telling us that we could have several combinations just because we don't know which will be the positive and which will be the negative number we need to work with. Also, the number 8, it does have, well, factors, combinations could be 4 and 8, or I'm sorry, 1 and 8, or 2 and 4. But we don't know which will be positive, which will be negative. So instead of doing all that guess and check stuff, we're going to turn this trinomial, remember it has 3 terms, we're going to turn it into a polynomial with 4 terms. So the way we're going to do that is by multiplying the coefficient from here, 3 times negative 8. So positive 3 times negative 8, and that will give me negative 24. Now I'm going to go ahead and list the factors of negative 24. And so we could have 1 and 24, 2 and 12, 3 and 8, 4 and 6. And we know one is positive, one is negative. Now remember how I told you that I like to list my numbers as this, small and large. Because now I'm going to use this sign right here, positive, and I'm going to assign the positive sign to the column that has the large factors because of the biggest absolute value. So if that is positive, the column of the small factors will carry the negative sign. Now from here, which combination gives me positive 10? And that will be negative 2 and positive 12. So now what I'm going to do is I'm going to break that term 10x, positive 10x actually, into negative 2x and positive 12x. And so that's what I'm going to do here. 3x, now instead of 3x squared, and instead of positive 10x, we're going to write negative 2x and positive 12x. And then, of course, we cannot forget about our constant term. Now, what I'm going to do here is I'm going to use the technique that we learned on the previous video, which is called factoring by grouping. Remember, that is a technique that we use when we have 4 terms. And what we need to do is make 2 groups and then factor the GCF of 1 group at a time. So the first group will be 3x squared minus 2x. Then our second group will be 12x minus 8. Now we're going to factor each group individually. So from the first group, we can only factor x. And if we factor x out of 3x squared, we will get 3x. If we factor x out of negative 2x, we will get negative 2. Now, our next factor from this group, both numbers, the 12 and the 8, could be divided by 2, but they could also be divided by 4. So that is what I'm going to factor out. So 12x divided by 4 will be 3x. And negative 8 divided by 4 will be negative 2. So now you can see clearly how this factor is repeating, 3x minus 2, because it does appear in both terms. We have it there and we have it here. So if we factor 3x minus 2 from here, we will still get positive x, which is here. And if we factor 3x minus 2 from here, we will get positive 4. And that completes the factorization of example 16. So let's move on to our next page. And last one. So far we have done one of this difference of squares. However, we're going to do more examples now. So to prove to you that this is true, let's go ahead and multiply the product of these two binomials. So a times a will be a squared. Then a times negative b will be negative ab. Then we will have b times a positive, so positive ab. And finally, we'll have positive b times negative b, and so that will be negative b squared. Now, if we combine like terms, like the ones here, that will equal to 0 because they have opposite signs. And so the answer to this question is a squared minus b squared. If I was to multiply these two binomials. If I want to reverse the process by factoring, that's what I will get. So the idea is that you take the square root of this one, you take the square root of this one, and then you make one positive and one negative, and that's it. Now, the condition, of course, is that there's a minus in between. It has to be a difference of squares, and also that both the first and the second term are perfect squares. So if we want to factor this one, and actually we did that earlier, so that will be x plus 3 times x minus 3. The next one, the square root of p squares, just the letter p. We make one positive, one negative, and the square root of 36 is 6. Or we could say positive 6 and negative 6. That is another reason why we have a positive and a negative. Because negative 6 squared is positive 36. Don't forget that. Now, right here, another difference of squares. So we factor as m plus 10, and the other one m minus 10. Now, for this problem, we still have a difference of squares. Square root of r squared is r, and the square root of m squared is m. And remember, we make one m positive and the other one negative. Now let's move on to example 18. So sometimes you could have things with more than one variable or terms with more than one variable, like this case, n squared and y squared. But we could still factor it the same way. So if we take the square root of x squared, it will be x and x. Then we already know that a positive and a negative sign will follow. Now the square root of n squared will be n, and the square root of y squared will be y. So we will have plus ny and minus ny. Our next example, now we have double variables in both cases. So the square root of the first term will be xy. So we put that here and here. And then we need to have opposite signs, so a positive and a negative. And I would take the square root of that second term and be r times p. And that will be the answer. Now, what we're going to factor next will be this type of terms, which the first one is considered, well, they're both considered perfect square trinomials. And the reason for that is that this constant term is actually a perfect square. And if we take the square root of 9, it is 3. Now, if you add 3 plus 3, you will get positive 6. So if I was to factor like we've been factoring everything, this will look like this. X, X. This sign is positive, so that tells me that both of my signs inside the parentheses will be the same, either both negative or both positive. But since this one is positive, we go ahead and make both positive. Now, factors of 9, it could be 1 and 9 or 3 and 3. So which combination gives me positive 6, positive 3, and positive 3? Now, what we could do with this one is we could simplify it by writing the two factors. Since they're multiplying each other, we could write it like this. X plus 3 square. Now, the next one is kind of similar. Except that in this case, both signs will be the same, but in this case, both of them will be negative. So we can write this as x minus 3 square. How could you recognize perfect square trinomials? Well, if the first term is a perfect square, and so is the last one. And moreover, the product in the middle will be the term in the middle will be the product of the first and the second factor, and then double. Now let's move on to a sum or difference of two cubes. And this example is not even too difficult, but in case you need to see more examples of difference and sum of cubes, I will recommend that you find a video from my YouTube channel on factoring either trinomials or binomials. I have several examples. So I started by rewriting 8 as 2 to the third power because that's what it is. And so just so that it can match our formula here. So now once I start factoring, I will take my first term. It will be the cube root of x cubed, so that is x, and then the cube root of 2 cubed, so it's 2. Now my second factor is actually going to be a trinomial. So that means it's going to have 3 terms, just like the one you see here. And so that will come from taking this x and we square it. Then we take this 2 and we square it. And then the term in the middle, if we started with a sum of cubes, then the term in the middle will be negative. So this will be minus, and it will come from the product of the first term and the second term. So in this case, 2 times x. So 2x. Now, of course, we could write instead of 2 square, we could write it as x squared minus 2x plus 4. And this one will be x plus 2. And so that is the last problem of this video. However, let's just go over this map or flow chart. So whenever you have to factor something, the first thing you should consider is there a GCF that is greater than 1? Because if there is no common greater factor bigger than 1, then there's no purpose of factoring out a 1. So you check that. Now you have to think, do I have two terms separated by one positive or negative sign? Or do you have three terms? Or do you have four terms? If you have four terms, then you need to use the grouping method. Now, if you have three terms, you need to decide if it is a product, the product of two binomials like we have here, or if it is, or this one's actually two, or if it is a perfect trinomial square. That one is not here on this flowchart. Okay, now if you have two terms, you need to check if it is a difference of squares. If you have that, then here is an example. If you have two terms and it is the sum of squares, just know that those are not factorable. The only ones that could be factored are the sum of cubes or the difference of cubes. So for that, we did that example. If you need to look at more examples, you could just Google any video on factoring, or you can find one on my YouTube channel, or you could use the ones that are embedded into your Math 0305 class. So thank you for watching. This is the end of the video.